Lefty, ladies and gentlemen. If you would, get logged in and go to joinpd.com. She couldn't bring it over to you. What a nice desk mate. She didn't know. Why didn't you tell her? Oh.
What was she going up to Mr. Brand for then? I didn't see her.
Maybe she was coming up to give me a high five. I don't know. Kiana, you gonna come up and give me a high five? Oh, look at that. She was like, yeah, I was going to, and then her friend says no. And then, you're awesome. You're awesome. By the way, ladies and gentlemen, do you know what today is?
No.
Today is National Brothers and Sisters Day.
I have a half sister.
So if you have brothers or sisters today, remember to tell them how much you like them.
I can't.
Not much. I'm pretty much saying the opposite.
Then you forget that it's National Brothers and Sisters Day.
I can't because my half sister don't live here, and I never met my half sister.
You've never met her?
No.
Then how did you? Okay.
I heard her. I seen her in photos. That's about it.
Okay.
I
Okay.
never met my half sister.
Well, maybe someday you'll get a chance
That's
to.
what I want to in my life. Is some try meet.
Is
How
she-
do you know this, Mr. Brand?
What?
A National Brothers and Sisters Day?
Because my sister sent me a picture of me and my brother when we were kids, and she said it's National Brothers and Sisters Day.
You gotta put that picture up of you when you were a child.
No, I don't have to.
Please.
I don't have to. I have no way. It's on my phone. I have no way of getting it onto
But
the
you
screen.
should pass your phone around.
No, that is an absolute no.
Send it to yourself via email,
Okay, I'll work on it.
and then you download it, and then you put it up there.
Okay, I'll work on it.
Okay.
He is not going to do it.
I could bring in the picture of Mr. Brand from 25 years ago.
No, we don't need to.
Do it.
We
This
don't
is
need
my
to.
senior yearbook.
We don't need to. 1, 2, 3.
You should so do it.
You should.
You'd be like, Mr. Brand needs to look like that? What?
Ooh,
He hasn't changed.
yeah,
He hasn't changed much.
that is true. The only thing that's happened is my hair has changed color.
R.I.P.
I've been through them all, Alex. I started out as a blonde, then I was dark haired when I was in my 20s or so, and now I'm white haired. So I've been through them all.
Were you in the emo stage?
Was I in the what?
Emo music.
Emo. What is emo music?
Early 2000s.
Okay. The early 2000s? Emo music? I've never heard of that. I'm sorry. Never heard of that.
The Wii came out.
Oh, yeah.
The Nintendo Wii came out a month after I was born.
He's from the 70s. You're right.
I can go see if there's any in the back. Yes.
These bands with like long.
All right. Yes.
Orange
Where's that here?
avocados. Calmly drive warm ninjas.
So apparently the other day, one of our soccer coaches here was a student here years ago too, and he brought in a picture of me coaching the girls' basketball team that was quite old. Let's put it that way.
I brought in a picture of Miss Howe when she was a senior and gave it to her. It's found at her desk.
Oh, that's awesome.
I remember what I look like. It's okay.
Can I come back and visit you, Miss Dart, when I graduated high school? Okay.
That depends on if you're ever going to graduate high school.
I want to graduate.
Oh no!
I mean,
He's gonna graduate high school. Even if I have to drag him across that finish line, he's graduating high school. I haven't put up with him for 3 years for him to not graduate high school.
I graduated because
Shut up,
I was
Kevin.
next year, so I couldn't see him
It's a true
in
fact.
half of what in half
Miss Dart, I'm back.
years
Wait a minute,
left
wait a
there.
minute. How can you have an untrue fact? Because by saying it's a fact, that means it has to be true.
Yes.
So why say it's a true fact? That's like saying it's a small, short person.
It's just something that we say.
Mr. Brand, can we get another charging block?
Sure. Anybody else since I'm going?
No, we're gonna wait till you get back and then ask another.
Then you're not getting one.
This is gonna be fun. It's gonna be that.
I have a good opinion.
Because remember, I don't have to give these things out.
Oh, you're right.
Of course I'm right. Why do you keep saying things that we all know is true already? All right. Get logged in, ladies and gentlemen. We'll get going on our pair deck. We'll do a little reviewing. And then, ladies and gentlemen, we're going to talk about half-life. Okay? We're going to talk about half-life, and we got a little lab to do today.
We're playing Half-Life the game.
Half-Life the game.
Yeah.
I have no idea what he's talking about. I don't think he even does. Half-Life the game.
Half-Life video game.
Oh, that's why I have no idea what he's talking about.
Me neither. I don't do video games.
I didn't know what he was talking
By the
about.
way, ladies and gentlemen, since Ethan's wearing his Brewers shirt today, there's a show I watch. I know I'm old. Leave me alone. It's called Top Chef. Has anybody ever seen it?
Yeah,
It's
I've
a
heard.
cooking competition, right? They go around different cities and they have a bunch of chefs and somebody wins $250,000 and whatever. They're in Wisconsin right now. They taped an episode in Wisconsin. Well, they taped a season in Wisconsin. So they've done that. Well, last night they had the racing sausages from the Brewers games. And each chef had to prepare a dish based on one of the 5 sausages. And then they had a group of people who judged them, and Ryan Braun, a former Brewer, was one of the judges on it last night. But so it's kind of interesting. They did one episode where they were down in Madison cooking at a farmer's market. Supposedly they're going up to Door County to do a fish boil at some point in time. So it's kind of interesting because it's our state that they're in, ladies and gentlemen. So, but anyway.
So how long are they in here? Like
the season is probably like 10 to 12 episodes or something like that, maybe more. I don't know. But they're not here now. They taped this, I would think, last summer. I think they taped it, and now they're just airing it at this point in time. So, but it's kind of interesting. So. All right, ladies and gentlemen, let's take a look. This is going to be about what we did yesterday, ladies and gentlemen. So we talked about the effects of radiation. We talked about how gamma rays have a certain amount of strength versus ionizations and things like that. So that's what this pair deck is going to be about, ladies and gentlemen. So here we go. Our learning target, you will be able to understand half-life terms and calculations. We're going to do the lab today. Tomorrow we'll talk more about the terms that are involved in it, but we'll get that done. So we're going to do the mini lab today. There is a graph that goes with it. We'll show you how to make the graph. The graph is done for you. But the other thing we have to do in today's lab is we have to collect all your data together. So you're going to do the lab. You're going to have your results, but then we're going to have an all-class average as well. So we'll be doing that today.
So we'd have individual in class.
What's that?
So we'd have individual in class.
You'll have individual and the whole class data, yes. And then, ladies and gentlemen, you have a test next week, Tuesday. So please keep that in mind. And by the way, next week, Friday, again, unless we have a snow day between now and then, you won't be
Shut
here.
up! Don't say it. We're gonna get one if you keep saying it.
You really think I can make the weather happen?
You never
You really?
know.
First of all, I am the one teacher in this department who roots against every snow day because I want that day off in May. So I am the one teacher who roots against everybody else. Oh, let's have a snow day. Let's have a snow. Why would you trade a day when it's 20 degrees below zero and snowing out for a day in May when it could be 70 and sunny?
Let me just ask this: if we on that day off in May, this month.
Yeah, let's get on with the question.
What are you gonna do?
Actually, I'll be going down to Whitewater because my daughter graduates the next day.
Oh, great.
So.
Congrats.
No, she's just graduating from there. She actually went to La Crosse, but they're letting her go to Whitewater for graduation. And yes, she went to Whitewater. Again, what kind of question is that, Faith?
I wasn't really paying attention.
That's okay. I'm sorry. I'm just being a jerk. It's okay.
La Crosse would have been a good school too.
My nephew went to La Crosse. GB would have been better, but I'm just saying.
I went to La Crosse.
Just saying, GB would have been better. Okay.
I plan to go to La Crosse.
My nephew was at two colleges. He started out at Oshkosh and ended up at La Crosse.
You would think that would be worse than going to La Crosse. you know,
What would be worse than going to lacrosse?
graduating from Preble.
Yeah, that
I
would be
agree.
worse.
Yeah.
That would
Because
suck.
I
That would be
graduated
worse.
from Preble.
Okay.
No, nothing against you, but
That's where I lived.
It's not her fault. It's not my fault I graduated from Algoma. It's my parents. So,
Okay, that would be worse.
are you kidding? Our graduation ceremony was like 30 minutes long. There were 75 kids in our class. Like, boom, 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 boom. Thank you. Have a good night. See you later.
oh, you want to keep? It was that quick.
No, it was just that quick because there were that few kids.
Okay.
Yeah, he had 75, I had 400.
Yeah. Yeah. Well, here's the thing. I came from a school where there was over 400 students in my class to a school where there was less than 400 students in the school. That's culture shock.
Oh, yeah.
All right. Which nuclear particle causes the most ionizations, ladies and gentlemen? Is it alpha? Is it beta? Is it gamma? Take your circle and put it on the one that it is, ladies and gentlemen. Which nuclear particle causes the most ionizations? This is from that table that we gave you yesterday, ladies and gentlemen. And again, if you don't know, take a guess, because here's the thing. Before you take the test, you can always find out what the actual answer is. All right, let's see what you chose. Good. Most people chose alpha, a beta, and a gamma. The correct answer is alpha, ladies and gentlemen. Alpha is the one that causes the most ionizations. Alpha is the one that will cause the most changes in cells when it gets to that. Which nuclear particle is the easiest to stop or protect yourself from? So this was the shield, this was the strength. Which one is the weakest, or which one could be stopped by a sheet of paper or even your skin? Okay, again, good. Most of you know that that's alpha. Okay? Alpha is the one that is the easiest to stop, but it is the one that, if it gets through, causes the most damage. Good, 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 good. Which nuclear particle has a high strength, meaning it can go through a lot of stuff? Matter of fact, you would need something like lead to stop it.
Somebody's at the door.
No. Yes, sir.
I am open from like 11 until, well, actually 10:30 until about 12:30. Every day.
I told the guys you joked. There was no reaction.
Yep. So, okay.
Here's the tea
Yeah.
that
Yep.
oxygen mediums in I don't get it.
Well, he said that about going above 2 because
I'm not like chemistry jokes.
at 45 degrees, it's not, you know,
I don't
it's
get
not a 90 in line, it's
These are horrible. That's a pickup line.
All right, ladies and gentlemen, let's see what you got. Good. Most of you got the correct one, which is gamma, ladies and gentlemen. Gamma is the one that is hardest to stop. Hardest to stop. Good, 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 good. Which of the following is an example of ionizing radiation? The radiation that is dangerous or harmful to us, ladies and gentlemen. Good. Most picked X-rays. That is the one that is harmful to us, ladies and gentlemen. Ionizing radiation is radiation that is harmful or that ionizes cells, changes them in some way. Okay? Which of the following is believed not to harm the body? Which of the following of these is believed not to be harmful to the body? Ionizing radiation, gamma rays, or non-ionizing radiation? Good. Good answer, ladies and gentlemen. Non-ionizing radiation is the one that is believed to not be harmful to the body. Again, we don't believe it is harmful to the body. Who knows? Maybe 30 years from now, we'll find out that we were wrong. Okay? But again, there's a lot of data out there. We know visible light is not harmful to us. Microwaves, we don't believe they are harmful to us. And again, radio and TV waves, we don't think they're harmful. But again, we're using cell phones now and things like that. People are using Bluetooth headsets. There's a lot more radiation around us. Who knows what we'll find in the future. All right, ladies and gentlemen, that takes care of our Pear Deck for today. Thank you very much. If you would, please go into Google Classroom. And in the classwork tab, ladies and gentlemen, find the Half-Life Mini Lab. It should be at the bottom. I'm moving it up to the top, but I don't think it's going to make it there before you guys open it up and find it, okay? But find the one that says Half-Life Mini Lab. And again, there are two files. There is a Google Sheet and there is a Google Doc. So if you could open both of those up, that would be great, ladies and gentlemen.
Are we working with a partner on these?
Yes, you will be. Okay? Now, this, ladies and gentlemen, I'll give you just a moment to get those open.
This class is just great, you know that?
Okay, so again, to graph some information, ladies and gentlemen, because again, in science, we love to make graphs. Graphs help us understand things. Graphs can tell us what kind of relationship there is. So one of the things you have is you have a Google Sheet, okay? You are going to fill in this part of the Google Sheet, ladies and gentlemen. Now, when you fill in this part, the average data here will automatically calculate for you, okay? So your average data will automatically calculate for you. But for the lab that we're doing today, it is good to not only have your set of data, and you're going to do the same activity twice. That's why there's two trials here. So you're going to have two trials. You're going to average them together. Then we're going to take all of your trials and average them together, and that'll be the class average. And that you have to get before you leave once everybody puts all their numbers into a spreadsheet for me. So after you are done with your activity today, ladies and gentlemen, you will have to come up here to the front, and on my computer up here, you're going to type in your data into this table so that we can get the average for the entire class, okay? So you're going to come up here and you're going to type in your numbers for trial 1 and your numbers for trial 2. Now, it doesn't matter what group you are. So it's not like Ethan, you and your partner are going to be group 1. Victoria, you and your partner are going to be group 2. When you come up here, just do the next ones that's available, okay? So you may come up and you may be group 4. Somebody else may come up and do group 6. Doesn't matter as long as you put your two sets of data in here, okay? Your two sets of data. Questions? We'll then get a graph and we'll show you what to do with that, okay? But here is the actual lab. We are going to represent something called half-life today, ladies and gentlemen, and we have not gotten into this yet, so let me explain a little bit about what half-life is. When you have a radioactive substance, it will break down and change into a new element, okay? Now, when it does this, ladies and gentlemen, it does it at a very, what we call, predictable rate. In other words, half-life is the amount of time it would take for half of your sample to decay away and become a different element. So if you started out with 10 grams of something that is radioactive, after one half-life, you're down to 5 grams of it. After 2 half-lives, you're down to 2.5 grams of it. That's what half-life is. How long it takes for half to go away. So you remember when we were talking about nuclear plants, and we were talking about the radioactivity in there. Well, they use nuclear decays to create energy. The problem is, after such a long time or so much time, the sample that was giving off the energy is decaying away. It's becoming something else. So because of that, there's less energy and less energy and less energy and less energy being released. And eventually it gets to the point where you can't make electricity out of it anymore. So then you have to get rid of that and bring in new material. New material that'll then, again, give off enough energy. Now, half-lives of certain things can be really short. Francium, on the bottom of the periodic table, is the most expensive element on the periodic table. You remember when we did that activity series where we threw things into water and they reacted? Francium is the most reactive metal on the periodic table, but we can't get any because 1 ounce of francium goes for about $250 billion for 1 ounce of it.
What about 0.1 gram?
Okay, I don't know. But it's got to be expensive still.
Probably. Yeah.
Okay, because 454 grams is 1 pound. Okay, 16 ounces is a pound. So 1 ounce would be about 30 grams. Okay, now here's the other thing about francium. Even if you were to get the money together and buy say, an ounce of it, after 22.5 minutes, radioactive francium, you'd only have half of the sample you started with. It's that quick of a half-life. It's literally 22.5 minutes, you would lose half of your sample. And then after another 22.5 minutes, you'd be down another half. So in our class period, which is 71 minutes long, ladies and gentlemen, if you started out with 1 gram of francium, it would go through 3 half-lives. And you would go from 1 gram to 1/2 gram to 1/4 gram to 1/8 of a gram in 1 class period. Okay? So it isn't really financially feasible for us to buy francium. Okay? Now, there are other elements, such as carbon, which has an isotope that has a half-life of 5,700 years. So it takes 5,700 years for half of a sample of carbon-14 to decay away, to become a new element. And if you've ever heard of something called radioactive dating, it isn't when 2 radioactive isotopes go out on a Friday night. What it is that, okay, if you were to make a pot in pottery class, there would be some carbon in there. And a certain amount of that would be carbon-14. Well, once you make this pot, it isn't exchanging any more. Nothing new is coming in, nothing is going out. So the carbon-14 that's in there, there should be a certain amount of it based on how much carbon there is. Well, if you put that pot and bury it under the ground, and somebody digs it up 10,000 years from now, they can look at how much carbon-14 there is and estimate how old it is. That is how they date artifacts for how old they are. They look at how much of the radioactive sample is left. Okay? So they know how much should have been in there on average, because right now there's a certain amount of that radioactive substance in your body. But if you were to die, ladies and gentlemen, and they buried you in the ground, you're not taking in any new carbon, you're not getting rid of any new carbon. So now, after a certain amount of time, the amount of carbon in your body starts to decay away, at least the carbon-14. And they can go back and they can estimate how old something is. Okay? Now, that's what half-life is. Half-life can be anywhere from seconds to thousands upon thousands upon thousands of years. It all depends on what the substance is. Depends on what type of decay it's going through. Okay? But the one thing that is very predictable about radiation is what is called this half-life. So again, with francium, you can never tell which atom is going to decay away. But what we can tell is over time, about half of them will decay away. Which ones we don't know, but about half of your sample will decay away and become something else. And that is very predictable. Maybe not exact, but very predictable. So it's not like, all right, I got 12.2 grams here. After one half-life, I'm going to have 6.1 exactly. No, but I'm going to be around there. I'm going to be around there. And this is very predictable. And we're going to try to simulate that today in the lab. We're going to simulate a half-life and see if we can predict how much will happen. Well, this is my favorite one to do, ladies and gentlemen, because the one thing I always say is you have a 50-50 chance of everything, correct? On a test, you have a 50-50 chance of getting the answer right. People look at me, well, there's 4 choices. Yes, but there's only right and wrong. So that's 50-50, correct? Okay. So if you take a penny, ladies and gentlemen, and you flip it, and it lands on the floor, what are the 2 possible results? Heads or tails? Heads or tails. That's it. 50-50, right?
Right.
Okay. Can you flip a coin? Tails, by the way. Can you flip a coin and 10 times in a row get heads?
No.
You can't?
You can, but it will be difficult.
Okay, then why'd you say no?
Because it will be difficult.
I didn't say it wouldn't be difficult, but can you do that? Can you flip coins and get the same heads or tails over and over and over again?
Yeah.
You can. But if you flip the coin 3-4 times, are you always going to get 2 and 2? Possibly, but are you always going to get 2 and 2?
No.
No. If you flip the coin 10 times, are you going to get 5 and 5?
Possibly.
Possibly, but not always, right? But if you flip the coin 1,000 times, 1,000,000 times, 1,000,000,000 times, guess what happens? The more times you flip it, the better chance it is it's going to come out half and half. Because maybe you get on a streak where you do 3 heads in a row, and somewhere else you do a streak where you get 5 tails in a row. And it balances that out and it evens out in the long run. Okay? If you take a small sample, yes, you could flip this coin 10 times and get heads every time. It is possible. Probably not going to happen, but it is possible. What are the chances of flipping it 1,000,000 times and getting all heads?
Do you 1 in a million?
Probably not going to happen. Not at some point in those times, it's going to go the other way, right? It's going to go the other way, okay? So that is what we are going to look at today. And what we're going to do is we're going to say, okay, an atom that is radioactive has only 2 possible outcomes for itself. It either decays away and becomes something new, or it doesn't. It stays the same. Those are the only 2 possible outcomes. Now, I can never tell when an individual atom will decay away. It may never decay away. It may not. But if I take a large group of atoms, I know that over a certain amount of time, about half of them will decay away. Which ones, I don't know, but about half of them will decay away. That is the predictable part of radiation. Not which ones decay, but how many of a sample in a certain amount of time. So what we are going to do today, ladies and gentlemen, is you're going to start out and you're going to do the simplest of labs, but people sometimes mess this up. So let me tell you what happens. You're going to count out 80 pennies, ladies and gentlemen. So at your station, there are a bunch of pennies. You're going to count out 80 pennies. And you're going to put all of your pennies so that the head side is up, ladies and gentlemen. So you go through and you count them and you flip them. Okay? Once you have your 80 pennies and they are all heads up, you are going to take them and put them into this plastic container, all heads up. A heads up penny represents a penny that has not decayed, just like an atom that has not decayed. So when we start out our sample, there are going to be 80 pennies all heads up. Okay? Now, I'm not going to put in a full 80 here, ladies and gentlemen, because I don't want to waste your time with me counting these out and putting them in there. But after you have your 80 pennies in the box, you're going to take and you're going to close the box and you're going to seal it up. And with all the pennies facing heads up, you're going to shake the living bejeebies out of it. In case you missed that, you're going to shake the living bejeebies out of it. Now, what are the two possibilities for the pennies inside here?
Heads up.
Stays heads or it turns to tails. Now, I will admit there is a chance you could have a third option. What would be the third option?
All the same.
One could be leaning up against the side of the box, kind of on edge. I suppose there is a chance, ladies and gentlemen, that I could flip this coin and it could come down and it could land right on its edge, correct? Probably not, but that would be a possibility. We don't ever worry about that, though. So if you look in here and you see a penny on the side that is sitting on the side, shake it around a little more, make a decision. Okay? Now, what's going to happen is you're going to open the box and you are going to take out every penny that has flipped to tails. Every one. Okay? If they have flipped, you're going to take them out. And now you're going to count how many are left. Now, if we start out with 80, how many should be left? Think about that.
Less.
We start, I understand less. I'm looking for
40.
a number.
40.
There should be 40 of them that are still heads and 40 of them should have flipped. It's a 50-50 chance, correct?
Yeah.
Does that mean it's going to be 40-40? I have seen it where there are 65 pennies left heads up. I have seen it where there's only 32 pennies left heads up. Okay? That's okay. You're not doing anything wrong. You take out the ones that are tails. You leave the ones that are heads in there, ladies and gentlemen. You count them and you put them in this table down here. Okay? Right now, in this box here, ladies and gentlemen, you can put 80, 80, 80, and 80. Why? Because that's what we're starting with. So everyone will start with that. A shake of the box, ladies and gentlemen, represents a half-life. Now, count how many are left in there. This number has to get what compared to this one?
Smaller.
Has to get small. Now, possibility it could stay the same. Probably not with 80. Possibility, though, but it should get smaller. After you've counted them, you're going to close the box again with just those remaining in there. You've taken out all the ones that were tails. Shake it again. None sitting on the side. Open it up. And again, I'm going to take out all the ones that are tails. Okay? Count how many are heads. Write the number down here. You're going to do this 4 times. 4 shakes. Now, if this were perfect, you should go from 80 to what?
40, 20, 10, 5.
I can almost guarantee you're not going to get that. Almost guarantee you're not going to get that.
Is it a possibility, though?
It is. It is. But what I don't want you doing is fudging your numbers. For those of you who don't know what that means, it means changing them because Mr. Brand said we should get 40, 20, 10, 5. No. Give me your numbers. Even if they're 60-some, 30-some, whatever it is, give me your numbers, okay? When you're done doing this once, you put all the pennies back in, heads up again, and you do it a second time. You do it a second time, okay? And then you're going to get your average. Now, again, ladies and gentlemen, if you put the numbers into this table here, it will automatically calculate your average for you. And can you have a half a penny?
No.
No. So the average here, because it understands you can't have a half a penny, is going to round this to a whole number for you. Okay? So that is what you would then put into your third column there. You would put that into this column here. When you all come up and give me your numbers, ladies and gentlemen, I will put them into here for you to see, and then you can copy them down into your lab and also into the Google Sheet. Questions? Okay. So, I don't know why, ladies and gentlemen, but this is just me. I can't stand that this is one font and these are another, so I'm going to fix that. There we go. Okay. So anyway, that's what we're going to do. Questions?
No, sir.
Okay. So partner up, go to a station, take your 80 pennies, get them heads up, put them in there. Please do not do this. This would be unfair to do in the lab. And that is to put them in there in a stack. Why?
Good fall over.
Okay, I'm not too worried about that. But right now, what would this stack of pennies have a hard time doing? They would have a hard time flipping. So please, spread them out in the bottom. Try to make a single layer. If you have to put a few on top, that's okay. But don't put a stack in there. And then remember, when you close it, okay, try not to shake it so hard that pennies go flying out, because if that's the case, you got to start over. Okay? But you can give it a good solid shake. Let it sit, and now take out all the ones that flipped over two tails. Get rid of them. Questions? Everything you need is back there, ladies and gentlemen. Let's go get it done. Let's go get it done.
Do you want to be partners with us?
I don't know if we had it or not.
See if everybody
We-
has If not, then you can mark yours up green.
Yeah.
Let's see if everybody has a marker.
I think there are 16 of us in class, though, so most groups should be 2. Ooh, hang on, though. Hang on. Kevin, Christian, and Ethan. Zoe, go back and you could work with Christian, okay? Thank you. Faith, you need a straw? You need scissors? Yeah, go ahead. Knock your socks off. By the way, take a look at your pennies too. If you can't tell which side is heads and which side is tails, don't use them. Some of them are pretty yacked up, shall we say.
Mr. Brand, why didn't you just count
Why?
the same more?
Okay. Can you not count to 80?
Yeah, we
Okay. I didn't want to count to 80 that many times. Again, remember, when you're done collecting your data, come on up here and put your numbers in up here. It doesn't matter which group you are. We'll put your numbers in up here so that we can collect the all-class average, because we're going to need it before you can finish your lab. By the way, when you take the pennies out that flipped, you can keep them tails up or heads up, but don't flip them back and forth, because you still got to put them back in heads up at the end. Working on it. We can take some from over by Alex's table. There you go. You're welcome.
Somewhere near 80. Oh, thank you.
Make sure they're all heads up when you start, otherwise it doesn't work for the lab. Take 'em. Now, all the ones that move over, out on your left.
Do we have how many potatoes?
What I want on the table is how many heads are left. Okay? Now, if you want to count how many potatoes, remember to seal up the sides too, because sometimes you'll seal up the front edge, the sides aren't sealed, and that's got a good beat. Now, I need it flipped over, and then you count on your left. Okay. Before you take the box, okay, please tell us how many are left. Yeah, now you got to make sure you just leave them in there. That's fine. You take them out, you get this set, one thing, so you can easily put that back in. The good news is you don't get the cup. As long as you keep them once you're taking them off that.
So it's like,
Seal it up after you pound it and got how many are left. Seal it up and then stick it again. And then when you're done, take it all the tails again and count how many are left.
And she is.
You could.
General science practice. It kills me.
Yeah, I don't know.
Emily didn't know what happened. I mean, every time I walk in here, every time I come by, I know what he's talking about. I can tell. Yes. Okay, I'm trying. I just need to stop with the anxiety of going to take it, and I just need to like look at a book for a week and try again.
So it's in that box ready to go for your numbers.
Yep, just type it in. Thank you.
When you guys are done with that, you should get into the sheet. Then we're going to be able to, you can actually start working on
What? It says group you put the first column. Okay, so the 21, 10, 5. Then is 39, 20, 12. I like that. I am tall as well.
You're like 5'3", kid.
I'm 5'5".
You're 5'5".
Yeah.
I'm a bit at 5'4".
5'4".
You're 5'.
He's the coolest.
I'm sure as fuck. I'm 5'6". I'm sure. You're not supposed to.
41.
Average.
Oh, the average. No. 18. 9. Where the hell is Mr. Brady? Oh. No! What did I do?
Did I throw you out?
No, I got it. Thank you.
Once you put them aside, you should do
Okay.
anything else.
No. Remember, type on my keyboard, not on your computer.
Yeah.
It's alright. I was trying to get it to there so you didn't have to use the mouse.
There you go.
Because the mouse is screwing you up. Yeah,
Yep,
Mr.
I got a
Bird.
weird mouse, sorry.
It looks weird.
Alright. Alright, there goes Zoe.
Great, man.
Three, eight, 4, 83, 18, 9, and 2.
Yeah. Don't worry about the mouse anymore. You're in the right spot.
Can I sign this? Can I put in my number then?
Alex did. Just hit enter. Or use the arrow down.
I'm gonna feel like Mr. Grant for a minute.
Oh.
Enter.
How's it going, Ethan?
Awesome. Sitting in Mr. Brand's chair can't get any better.
We had a few mouse issues, so I've just been
I know. I know.
standing and helping when they have mouse issues.
Yeah. Yep. Thank you. You want to type them or do you want to just read them to me? Okay, what do you got? 80, then what? Yes. Okay. 21. Okay. Then 1 and 5. Okay, excellent. Thank you. All right, please listen, ladies and gentlemen, so that we can get this information in for you before class ends. So here are our averages. Hang on a second. Okay, so these are the numbers, ladies and gentlemen. 80, 42, 22, 11, and 5 that go in this last column. So let me read those again for you, but this is where you're going to put them right here under the class average on here, and then you need to go back into your Google Sheet and put them into your Google Doc and put them in there. So once again, ladies and gentlemen, those numbers were 80, then 42, 22, 11, and 5.
You put in the numbers.
So those are your numbers right there, ladies and gentlemen.
Not working.
What's not working,
No,
Zoe?
because my thing keeps telling me to reload. Check my internet.
Okay, it'll get there.
And I
Just easy. When you click on it 400 times, it doesn't do any better for you. Okay. Okay. So we had 8 different groups do this lab 2 times. That's 16 times, correct, ladies and gentlemen? Look at the numbers. Do any of them work out exactly 40, 20, 10, 5?
No.
No. And this is real life. This is what radioactivity is. It's probably not going to be exactly half. But when you come over here and we take all of these numbers and add them all together and average them all out, ladies and gentlemen, now we come pretty darn close, don't we?
Yeah.
80, 42, 22, 11, and 5. We come pretty close. And actually, you know, it's not bad. It's not bad. And this is what happens in the real world in radioactive decay. Yes, it may not be exactly half, but it's close enough that we could say, you know what, this is what the half-life is. Okay? And the larger sample, if we take your class and put it together with my 5th hour, normally we get even closer then. We get even closer because the more data that we take, okay, a lot of you were, higher than you should have been at the start. A few were lower, and it averages out.
So this person was 7 under, this person was 5 over. Well, that's pretty close to being right on track. But then look, ladies and gentlemen, you know, when you get down to the bottom, this person had 1. 1. Okay? This person had 2, but this person had 8. So again, maybe this set of data for this person wouldn't have been great, but when you average it all together, now I'm going to randomly steal 2 groups, ladies and gentlemen, just so that I can put the numbers in to my table and we can take a look at them and I can show you what to do. So your table here should look like this, ladies and gentlemen. It should be complete, right? Make sure you take these numbers here that you just typed into here and make sure they go into this table here, okay, under the class average, because that's the one that we did not have, okay? That's the one that we did not have. You don't have to change these. I'm just changing these so they match up to what's in here for groups later on, ladies and gentlemen. Okay, that's all I'm doing here. Okay, all right. Now, we are going to have to insert a graph here, ladies and gentlemen. So let's go back to our Google Sheet. And the graph should be made for you, ladies and gentlemen, and there should be 2 lines on it. Line 1 is your average data, and line 2 is the class average data. Now, what do you notice about these 2 lines?
They're pretty similar.
They're pretty similar. Good. Give me something about the shape of them. They're going down. What does that mean?
And it's curved.
It's an inverse relationship. As the number of half-lives go up, the amount of sample goes down. And it's a curved line, meaning it's not what? Meaning it's not constant. Good, because we weren't expecting this to be constant. Okay? Now, 3 things need to be done to this graph before you can take and put it into your lab. Number 1, you need to change this label in units. Now, 0, 1, 2, 3, 4. What does that represent, ladies and gentlemen?
Number of shakes.
Well, we're calling it the number of what, though? No. Go back and look at your table. What did we call that first column? Half-lives. The shakes was what you did, yes, but that represented a half-life. Now, here's what I'm telling you. Please listen. What is the unit for number of half-lives? There is no unit because when you say number, it means you did what? You counted. That's your unit. So when you click on this label here, ladies and gentlemen, and there's 2 ways to do this. Edit chart, customize, chart and axis titles. So here is the title. Here is the horizontal axis. On here, ladies and gentlemen, you can put down number of half-lives. Okay? What is the unit on the x-axis, on the y-axis? We call them headsiums. Again, number of, because that takes care of your unit. All right, we'll see you tomorrow, ladies and gentlemen. We will finish that. Good day today, ladies and gentlemen. We'll see you tomorrow. Have a good day. Goodbye, goodbye, goodbye. Go away. Thank you. Thank you. Thank you. Thank you. Kevin? Thank you. I was going to say, you should already know by now.